So this is basically a business in US, and they sell second-hand clothes in US, and they are the largest ones. So they have more than 130 million investment. They are, I think, 7 years or 8 years old. They have more than 1,000 employees. Why? Because they decided, to beat the competition, to go from purely online business to really offline business. So they have 4 distribution centers, they even have physical stores, and that's why they have like 1,000 employees. In engineering, we have less than 100. So I give a stage to Tatiana, and she will talk about marketing case.
Thank you, Anton. So since the time I joined the thredUP, my friends keep asking me the same question. Why do you need machine learning for online consignment store? The truth is we need a lot of machine learning. We apply it at marketing department, merchandising, operations, finance, and sales. And at all these departments, we apply it on the very high level, and we use cutting-edge technologies there. The first department I was working at is marketing. I was really pleasantly surprised to see that our marketing department has big data in place, and they are ready to adopt new models, new approaches to benefit from it. Today, I would like to talk about omnichannel attribution and benefits of this approach. What is omnichannel attribution? Every e-commerce site has to monitor clients, starting from the first visit on the page up to purchase or conversion. And within this user journey, we have to try to stay in contact with our users via different channels like paid search, social networks, emails, and we try to optimize these channels and optimize our spends. And there are a lot of so-called attribution models which provide credits for those channels for leading users to our site. And being honest, the most commonly used attribution model is the model when only one of channels gets all the credits. For example, the last channel user was looking for our site before purchase. And the most advanced approach is omnichannel or multi-touch attribution model when we credit the channel depending on the importance of this channel for users' purchases. What challenges do we have here? First of all, we have a big data challenge. We have billions of clickstream events. Our users visit our sites daily, and they produce thousands or hundreds of clickstream events. They are looking for items, they're clicking on items, they're changing pages, they can spend hours at the site, and we need to deal with all these events and find appropriate data processing solution. Second challenge is data modeling or algorithmic challenge related to the fact that we are literally looking for a needle in a haystack. Why? Because typical conversion rate for e-commerce site is 2–3%. So you could imagine that we have to take all users who visited our site and never made a purchase and try to find those users who may make a purchase soon. So it is an extremely unbalanced sample, and we need to find the way to deal with this. Let's talk about the first challenge, data processing. First of all, our marketing department was working with clickstream data for the first time. They were not aware of what insights they may have there. So they asked for a really quick proof of concept project to decide what next steps we can do in this area. We have raw clickstream events in Parquet, but some of these events are replicated in Redshift. And to do a quick proof of concept project, we use user data from Redshift, clickstream events from Redshift, processed everything in Python, and used sklearn to do a predictive model in Pad. This approach was good. We produced some proof of concept model to discuss with our business users, but we were able to process less than 10% of all users. And when we decided what actionable steps we will do after that, we moved to processing using Databricks. We took raw clickstream events from Parquet files, processed everything in Databricks, and again applied sklearn on top of this because MLlib doesn't allow to weight classes during model fine-tuning, and since we have our unbalanced sample issue, unbalanced sample problem, we have to deal with class balancing. It was essential. Now, how do we weight our channels? How do we produce these weights from our clickstream data? We took all our user events. We filter them down to define unique sites visits or unique touch points. What does it mean? User can Google our site organically, visit our site, click like 100 of different pages. We will have record of this data, and having all these records, we define that this user visit at this time was driven by Google, and we have unique touch point, Google, here. So you can imagine that some users may sign up for our service like a year ago, visit our site dozen times, and we will have to go from this huge data to this unique touch points. So we completed the filtering, and after that, we, using these unique touch points for every user, tuned a model to predict conversion rate. We predicted conversion rate for all our sample. After that, for every channel, step by step, we were assigning interactions with this channel for every user to 0 and recalculating predicted conversion rate for all our sample. And for every channel, difference between this predicted conversion rate and this artificially predicting conversion rate, assuming that interactions with given channel did not happen, is weight for the channel. If you sum up all these differences, you will have 100% weight, and having these weights are literally these weights here. So after some minor transformations. At this step, our marketing department was happy. They were super excited. They said, it is interesting, it is new, we have this new knowledge about our clickstream data. Can we do something else interesting and cool? Yes, we can. And the next actionable results we got from our data was retargeting optimization. What does it mean? We have the same data. We have unique site visits for every user. But now we try to predict if a user will click on the paid ad and make a purchase after that. To resolve this problem, we tuned two models. One model was predicting conversion, and then another model was predicting click on the paid ad. We were combining two outcomes of the model, two probabilities, to get chances that likelihood that user will click on the ad and make a purchase. Why do we made two separate models? As I said before, this problem, we are dealing with really extremely imbalanced sample, and target rate for our events is super low. So if you took two different events, your target rate will be a little bit higher and models are more robust. So this was a decision to have a robust outcome. And from modeling perspective, we selected gradient boosted machines as an algorithm and recall metric to tune models to optimize performance. And recall metric was also selected because of this imbalanced problem. It helped to focus on our low target rate. So, what are business insights and impact? First of all, our marketing department has this graph. This is the toy example. Unfortunately, I cannot add actual weights to this graph, so you could imagine it is directed and have weights, probabilities of going from one channel to another at each line. And it was a kind of visibility for user journey. And we had a model allowing us to find a good user to target our ads towards these users. We have a model with recall metric over 75%. And having all this in place, we expect to improve our retarget efficiency by 10%. And 10% is a material effect for the big company with a big marketing acquisition budget. And I will be happy to give a microphone to Anton and to talk about another use case in a different department, also super excited.
Thank you, Tanya. So I would add one comment here is that at this level of investment, like 130 millions, you can imagine that millions of dollars are spent as a marketing budget. So basically, Tanya joined in spring. They run this project, and it really makes a difference in millions of dollars for the business because of this project. I will talk about another case, and there is actually a lot of data science here, and I'm an engineer, so I will highlight more like an architecture, and I will show you why we use like the simplest model, or not the simplest, but well-known model, and we got, again, results that saved like millions of dollars for the business. So for that, I would need some background information. So we used machine learning for inventory balancing. What is the inventory in e-commerce store? So all the items that they sell is in inventory. In this case of this business, every item is unique because, for example, you have like 5 dresses of the same brand, same size, but they were supplied by different suppliers as a second hand, which means you need to handle every single piece that we receive in distribution centers, like specifically. With this inventory, so why do we need to balance the inventory? And what's that? So we have 4 distribution centers. They are spread geographically in US. So for example, one in Chicago, one in San Francisco. You need to keep kind of all your inventory well balanced. Like if you have a winter clothes going to the distribution center, you need to decide where to route this. right? And also you need to decide, because we are marketplace, so we are selling not our kind of inventory, but our suppliers. We need to decide, are we able to sell this item, or should we return that, or we recycle this item? So basically, one of the like mission points of the thredUP as a business, they recycle responsibly. So this is the motivation for suppliers to send their clothes. Then, when you have the item, you also need to balance what you list on the website and what you stockroom. Why would you want to stockroom the item? Because, for example, you have a swimwear in winter, so you get that. So you will probably sell this for the low price. But if you stockroom this item and sell this in summer, you will get the full price for this item, right? And there are, tons of decisions also. This is if you think about the business, this is the merchandising and operation side. So you need to decide what kind of discounts to apply, what should be the price for this unique item. We have 3 physical stores, and we need to do the replenishment. Like they sold some inventory. We need to decide what kind of items we want to send to these physical stores. And we need to decide what kind of sales campaign. So all these areas are subject for machine learning there. Now, I will talk only about one decision here. And this is a very important decision, also $1 million decision for this business. Do we sell the item, do we recycle, or do we return that? So recycle and return, it's the same kind of thing. If clients paid to get returned items, we return them. And we decided to go with the likelihood of being sold. So the likelihood of the item being sold in the next 30 days. And so, wow, it's a binary decision, binary outcome. So the item is sold or it's not sold. Okay, why it's good? Because we can use logistic regression. And if you remember the talk like machine learning goes live, there was a statistic like 60% of all the algorithm, like in all the data science, 60% is logistic regression. The same for us. So the model like from 60s last century, and I will show you what was the accuracy. For the model training, we selected 30 days. We played with different, historical, but 30 days means for us that we need 60 days to form a training set, because we accept like from first 30 days we accept the items, and this is our kind of training set, but then we need to wait another 30 days to find out whether the item was sold or not. So, and then we decided, or basically we tried different things, and we stop it on, we trained the model over the weekend, and then we use this for prediction over 1 week. And this is our sliding window. So as you can see on the slide, so we just train the model every week, and we do this on the historical data of 60 previous days. We tried also not only this, because we have like 5 years of history or 7 years of history. We tried also to take historical data from the previous year, because this seems a better solution, right? Because, for example, if you think about 60 days, so today is November, right? So we make a decision whether we will sell this item based on the date of, I don't know, August, September, right? On September. But what you sell in September, you do not sell this in November. So we tried the model when we took the November data, but from the previous year. And accuracy of this model was better. I mean, so it means that in this business, recency is more important than, the real historical data of the previous year. So one of the ideas now for refactoring is if we combine 2 models, like we train one model on the historical previous year and another model on recent data. So these first 2 decisions was really more or less simple to do. However, probably in all the data science, at least, so as a software engineer, I participated to several projects already with data science. It seems that the most efforts, they go to attributes. What kind of features we select, how we collect them, how we transform them, how we prepare them, and then, to coding, how we feed this to the model. And here we separated attributes to 2 parts. One was the attribute of the actual item, what is the brand, what is the price bucket, what is the gender, what is the category of this item, is it a dress, is it a sweater, and then another set of attributes, we call them aggregations, it was attributes where we, by the attributes of the item, category, brand, gender, and so on, we define like similar items. And for these similar items, we take historical data about demand and supply of those items. So if you think about likelihood to being sold for the item, if you know like what is, if you know what is the, if you know what is the demand for this type of items, if you know what is the supply of this type of items, if you know what kind of inventory we have. So, for example, I mean, if you have on the site only 2 dresses, of course you will sell them, right? But if you have like hundreds of thousands of dresses and you get a new dress, probably likelihood will be smaller. So basically our attributes to train the model were attributes for the, our features were attributes for the item, and then features that we are describing demand and supply for similar items. So after we defined, and basically those attributes, they were not defined like before the modeling and before training the model. So we fine-tuned those attributes with the model already. So our gold sponsor is Azure from Microsoft, but we were on Amazon. And of course, that's why we went with the Amazon solutions there. So our main application that serves an e-commerce website is written in Ruby on Rails, and data is hosted in Amazon RDS. And so we used Amazon data pipeline to transfer this data into Redshift. So Redshift is the data warehousing system on Amazon also. And all the calculations for these aggregations, like counts of items, counts of supplied items, counts of sold items, they were calculated on top of the Redshift. And item attributes and also these aggregations were transferred to, again, relational database to the application that is called thredUP Tetris. So this is basically an application that wraps and implements this machine learning and productizes this model. And for actual machine learning, so we used Amazon machine learning. And so they have logistic regression there, and it was kind of an obvious choice for us. That's why I say that we don't really have, a real machine learning in this project, because, the actual machine learning was outsourced. And our clients accessed us with the RabbitMQ messaging, if you know it's message broker, and we had an SLA to feel like we need to make a decision in 2 seconds here, and that was fulfilled. So about lessons learned. So now we have this likelihood, and it's already used in business making 2 decisions, whether we sell or recycle the item. And we also decide whether this item is a consignment item, which means that supplier really takes care of the pricing and everything, or we buy out this item from the supplier because we know we will make like a better profit out of that. And so, like, not the simplest, but well-known model logistic regression with the attributes we fine-tuned, we got to accuracy of 90%. Because we if we recycle the item, we don't know about negatives, right? So because we recycle them, we cannot sell them. So in order to have a feedback about our model, how it works and so on, and also to fit the model with the new data of like neutral set, we also randomly select 2% of the items back to the inventory and we sell them. So despite the fact that we decide to recycle the item, 2% still gets to go into sales, so that we know how our model really predicts whether it's good or not. And the main kind of take-home message here is that the idea on the start of this project was like, let's stop coding like complex rules and everything for dynamic system. Let's just use machine learning for dynamic system. And so everybody was excited. We implemented this model, and then business rules, they strike back, because you cannot really. If you want to implement all the business rules, the model will be too complex, really, to support that, to productize that, and so on. So if you want to have a holistic approach as an engineer to some problem, you need to combine machine learning and business rules to keep simple machine learning and to keep simple business rules. So Please, your questions.
I have two questions. Well, first one is related to the business part of what you did. I know that you probably have an NDA, so what were the absolute values of the impact you delivered, like maybe in ROMI or in LTV? And second question is, having this project implemented, what you would have done differently, knowing that like you've done everything you could already? And what are your thoughts on the project now? What would you have improved?
Tanya, do you want to go first?
Is it question for both?
I think both of us cannot answer first question.
Unfortunately,
In absolute, absolute money numbers, we cannot say that. But I can say that, marketing budget was millions of US spent on Facebook advertisement and Google, and you can do the math because Tanya shared that, it was a 10% ROI there, right? So you can calculate the impact there. For the impact on this inventory balancing. It's hard to say what is the ROI because we recycle the items that we do not sell. At least it works, and business is satisfied with that. And the most important thing there was from the operation side, because on the distribution center, it's really we receive like thousands of items per day for the distribution center, and it's really a process because we need to measure the item, we need to check the quality of the item, then the photos are taken for this item and so on, and those are very expensive operations. So this model allowed us to decide whether we accept or reject very early on this process. So the cost savings there are very, very big.
I would like to also address your question. So maybe talking about 10%, especially if you have no absolute numbers in mind, doesn't sound that cool. And I would also add that I was not approaching it from the scratch. I mean, retargeting optimization. Before that, we have a quite comprehensive model in place, which already helped us made a big move in retargeting efficiency spend. And one of important impacts of the model I presented was ability to find up to that model to make another step and having the data which was not used before to find a new user segment to narrow down our population for retargeting spend further. So, let's say it was something 10% of the top of maybe 50% improvements, and it's harder and harder make to every next step here.
Okay, thanks for your cases. My question is about attribution. Why did you use machine learning at all to solve this problem? There are a lot of good statistical models that can solve this problem, like Markov chains models or funnel-based attribution. Did you try these models? I think in your case, it might be much cheaper to solve this problem using that models than apply all this machine learning stuff.
Thank you for a good question. First of all, I would like to emphasize that attribution, like multi-channel attribution, was a part of research R&D project to understand what do we have, what insights we can have from clickstream data. And if you mentioned the deliverables from that was aimed to improve our retargeting efficiency. Going back to multi-channel attribution, if you have like 5 different channels which user was interacting with during different steps of his user journey, how do you assign weights to these channels? Like this approach with machine learning is one of the cutting-edge new approach. There are quite interesting papers on that. For example, Netflix is using the same approach to assign weights for the channels, and we were excited to test how machine learning will help us to weight our channels and to see how it works. And again, going back to statistician methods, you will have to think how to weight these channels depending on the time when user interacted with given channel, depending on some cross relationship, etc. So machine learning somehow simplified all this.
Thank you about your presentation. It is really interesting field of marketing, you know. If you go back to the last slide, I just wonder, how did you come up with this 2% of negatives?
That was just, engineering decision. You mean how we justify 2% or 1% or 3%?
Yeah.
So, as I said, we get thousands of items per day, which means that we basically cover our category. We have quite an advanced taxonomy of the categorization for the items, and also different gender, different sizes, different brands, and so on. So we just calculated that 2% will be enough for us to, even train the model only on this 2% plus 2% of positives, not take even the whole data set, and it produced the same kind of accuracy. And that was the idea, that we can always switch to the kind of really natural set, because here we are affecting. So what I mean, so we train the model, our model decides what we are going to sell and what we not sell, which means that for the next model trained, we already affected the historical data, right? And we wanted to have also this way back, like, we can have a really neutral, without the impact of the model, we can have a neutral set to train some model. And after a couple of months, I think, we also run the model training on the neutral set. So these 2% of randomly selected negatives and 2% of randomly selected positives. And we trained the model, and accuracy was almost the same. So, and we are able to do this, model verification over time. So, but 2% was justified just by the numbers, how items we have in the inventory, and do we cover, do we well cover all the groups of items there, categorized by size, gender, and so on, and pricing. Okay, thank you.
Thank you. Oh.